Hi, let's move on to Module 3 of our Database Development and Design 1 slide deck. So Module 3 is about SQL. And whereas previously we've just sort of skirted around talking about the actual programming piece, we've seen the query by example graphical user interface that Access gives us. Really what we want to learn in this class is how to program the database. And we program most databases, most relational databases, using SQL or the structured query language. So this is what we want out of the this module. We want to look at the SQL. We want to be able to create tables and fields using SQL. We want to be able to get data out using SQL. We want to use various operators to make complicated queries using SQL. We want to be able to create calculated fields or computed fields. We want to be able to use wildcards and the like and in operators. We want to use built-in aggregate functions. We want to be able to group records, and we want to be able to do subqueries. Also, we want to be able to use those relationships that we talked about, the one-to-many potentially relationships between tables, to join tables. We want to be able to take two queries and put them together and get the union of their outputs. And we want to be able to change the data, update a row, insert a row, or delete a row. And we can talk about database career with SQL skills. So you would have seen in Microsoft Access that most queries have three views. You've got the data view, the query view, and the SQL view. And what we're doing in this module is to look at the SQL view. It's just a code editor. Usually it's good to have a fixed width font, but it doesn't really matter. The SQL view default font size is 8 points. Maybe that's too small. Sometimes a bigger is better. And the default font is not monospaced, so you may want to change it to 12 points instead of 8 and change the font to Career New. Right, so here's the view onto Microsoft Access, and we're building a query. So that query editor is just like a text editor. You can select stuff to delete it, you can cut it, you can paste it, you can do whatever you normally do with a text editor. And when you think you've got the query correct, you can change the view to see the results. So probably the first thing you might want to do if you've got a blank database is to create a table. And funnily enough, the SQL for making a table is just called create table. Now, as with many programming instances, it's good idea to think before you do stuff, particularly thinking about how you name your tables and how you name the fields or the columns or the attributes of those tables. It's usually not a good idea to have every table have a field called ID, just because it's hard to then figure out in a complicated query which ID you mean. It's also a good idea to avoid having spaces in names or having special characters in the names. Upper and lowercase characters are okay. I tend to use a very simple rule which says no spaces, no cases. So for a lot of the things I do, everything is lowercase and there are no spaces in any of the names. If I do need a space, or I think having a space is a good idea to make things understandable, then instead of using a space, I use an underscore character to separate words. And that's what the slides suggest as well. The other thing you've got to figure out when you decide to create a table, apart from the name of the table and the name of the fields, is what are the types of each of the fields. And this is just a short list of the possible types in SQL. Usually the ID field you want to be auto number. That means you don't make up what that number is. The database tells you what it is, and it adds 1 to the previous value that it knows about. So it'll start off with 1, and then the second one will be 2, etc. Sometimes you want to store currency, or date times, or lots of text, or a number, or a small amount of text, or just a flag, yes or no. And all of those are available. There's 4 operations we usually want to do with the database, and it uses a silly acronym, CRUD, C-R-U-D. The C-R-U-D stands for create, read, update, and delete. Generally, the most you're going to do with a database is that read operation. And in SQL, read operations start with the keyword select. And there's usually 3 pieces to the query. It's select, from, and where. So select tells the database which fields you want to show. From says which table those fields are coming from. And the where puts any conditions on or filtering on top of what you want to do, in case you don't want to return all of the data. Right, so here's a simple example. Select star. Now often we want to get all of the fields out of the data. So there's a shorthand using that asterisk, right? So select star will bring all of the fields out of the table we're querying. The table we're querying here is the clients table, and we're filtering on the zip code field of the table, and we only want clients whose zip code is 01431. Now, zip codes are really quite painful when it comes to databases. They look like numbers. They are not numbers. They are not numbers in the usual sense, because oftentimes they start with a 0. For example, all Connecticut zip codes start with 06. I think 01 is Massachusetts. I could be wrong. I only really know the Connecticut numbers. So that's why instead of just saying zip equals 01431, there's apostrophes or single quotes or quotation marks or double quotes around the text, because this is a text field, it's not a numerical field. When you're filtering, oftentimes there's more than one criterion by what you want to filter. So you can use logical operations and, or, between, in order to filter a bit more specifically. And so the difference between and or, and says both things on either side of the and operation have to be true. Whereas the or operation says that either condition needs to be true, both do not need to be true. So it's a little more encompassing than the and operation, and limits things more because both conditions have to be true. There's also a between operator. So this is particularly useful for dates, where we want to say we want to get all hire dates in the year 2020. So here we say where hire date between 1st of the 1st 2020 and 31st of the 12th 2020. Sometimes we want to invert the logic of what we have. So we want everything but the category ID coding. So here we use the not operator. So that the query down the bottom there says where not category ID equals coding and per equals hour or per equals hour. Not quite sure why the two of those are there. They look like they're the same thing. Anyway. I think we talked about before that sometimes you don't want the exact data in the table. You want some calculated version of it. And here are some of the things that you can do to create a computed field. You can add, subtract, multiply, divide, or concatenate. One reason you might use concatenation is if you just want to show the person's full name, and the fields you have are their first name, middle initial, and last name. So you can concatenate those three together in order to get their full name as one thing. So there's various reasons why you may want to have a wildcard operation, and wildcards are just a pattern that matches everything, right? So we use the asterisk or the star character to do that. Some versions use the percent sign, but generally it's the asterisk character. Another operation that we may want to use is we may have only distinct values in a particular field on the database, and we may only want 2 or 3 values of that particular field to be in the information that we read out of the database. So here, title could be one of database developer, front-end developer, or programmer. And we're assuming here that the employees table has a field called title, and that these 3 values are valid values of that field title. You might want to sort records, and here you can sort by ascending order, and usually you use the keywords order by, and the default order by sort is ascending order. You can also explicitly state that by using the keyword ASC. If you want to go the other way and sort in descending order, you can use the DESC keyword. You don't have to just use one field to sort by. You can sort by, first of all, the major key, then any minor keys. And each field that you're sorting by can be sorted either ascending or descending, independent of the other fields. But you list the sort keys in the order that you want them evaluated. Primary key or major key first. We've talked about aggregate functions before, but they're built-in functions that are part of the SQL language, and the functions are sum, AVG for average, count, max for maximum, or min for minimum. And they all work as you might expect. Some of them don't work for textual data, but count, max, and min do. Sometimes you want to group together records that have the same value and then use aggregate functions on those grouped records. So to do that, you often use the having clause, which is different from but analogous to the where clause. Both where and having are usable in the single query, and we won't do it just yet, but we'll do in a few examples about how to use where versus having. Some queries are more complicated than just select from where. Sometimes you need to do a bit of pre-processing on the data to only get the information that you want to work on, and then you want to write a query on that information. And this is where subqueries come in. And in fact, as the slide says, you want to break the query or the question down into two steps. And SQL handles it by putting one query inside another. The inner query is called the subquery, and it's evaluated first. And once that's done, the outer query is evaluated. So here's an example. The inner query, or the subquery, is select salary from employees, where employee ID equals 65. So that's getting a particular employee's salary value. And then the outer query says select last name comma salary from employees where salary is greater than that value that we pulled out. So what this query is doing is trying to find all those employees' last names and their salary where their salary is bigger than employee ID 65's salary. So that's an example of using a subquery. I talked about relationships between tables, where we have the client ID field on the client table and the client ID field on the project table. And that says there's a relationship between those two tables. The way we use that relationship in SQL is by joining the tables, joining the client ID in the client table to the client ID in the projects table. And the way we do that is with a where clause often. Right, so here's a client, and we're saying select client ID, client name, project ID, and project notes from the two tables, clients and projects, where clients.clientID equals projects.clientID. Notice we have to disambiguate, we have to let SQL know which client ID we mean in both cases. And the first one is the client ID on the clients table, and the second one is the client ID on the projects table. and then we're ordering by two things. We're ordering by clients.client ID. Again, we have to disambiguate which client ID we mean because both tables have client ID on them. So we just do that by prefixing client ID with clients dot, and then the secondary sorting is done by project ID. Sometimes we want to put together output from two different queries, and we do that using the union operator. Both queries must have the same number of fields, and the corresponding fields must have the same data type, otherwise you will get an error. So here's an example. We're pulling last name and salary from the employees table. And the first thing we're doing is finding all of those employees with a salary of more than 7,000. And then the second thing we're doing is we're finding all those employees that are employed on projects, or perhaps they're managing the project if their employee ID is on the project's table. Okay, those two queries give completely different, or maybe overlapping, but distinct results, and the union operator allows us to get all of that information in one hit. So the next piece, update, where we want to change data, we use the update and set keywords. So here's an example where we want to change the salary field from a monthly value to an annual value. And it says we update employees and we set salary equals salary times 12. Now sometimes, some versions of SQL, some databases, will not let you do this. And the reason it won't let you do this is this update is going to be applied to every column, every row in the database, every row in the employees table, to be precise. And sometimes you don't want to do that. So what they do is they also require that a where condition is applied to the update query. If we want to insert something into a database, once we've created the table, there's no data there, we have to insert. So we use the insert into table name clause and then a sequence of values. Right, so here's an example, insert into employees with values those, and each field in the table has to have a value. Otherwise, you may still be able to do it, but before you, the values keyword, you need to nominate which fields you're inserting in data into, and that'll tell the database which ones you're not giving information for. Deletion is done using the delete keyword and delete from. You should also use the where clause. If you don't use that where clause, then you will delete everything in the table. Right, so delete from project items where project ID, project line items where project ID equals 11. Right, so that's a reasonable deletion. So everything associated with project ID 11 is going to be deleted. Access tries to stop you from deleting stuff too quickly, so that you may get a pop-up like this to say that you're going to delete 7 rows, and is that really what you want to do? Sometimes you want to be able to take a query output and store it into a temporary table. And that is perfectly acceptable and doable using SQL. and you do that using the into keyword and followed by the name of the new table. You can also, I believe, insert into an existing table, but you have to be very careful that everything matches in the existing table case. So SQL is the thing that is often used for accessing databases. But just about every language that I can think of, certainly Java, Python, JavaScript and C++, use SQL in their own vernacular. So it's really best off that you learn SQL first before trying to access a database in Java, Python, JavaScript or C++. SQL is pretty universal. It's mainly about relational databases, but Oracle, Microsoft SQL Server, MySQL, Postgres, trying to think, there's probably a couple of others, Maria database, they all use SQL as a way of interacting with the database. So it's a really good way to understand data, and then from there you might be able to understand how to program using databases, but you're better off starting with that SQL knowledge. Okay, summary. SQL is a language used to create, manipulate and select data from relational databases. We can use the create table, data definition language command to describe and create a new table. We can use select queries to read. We can use where to filter. We can use order by for sorting. And there are computed fields that we can use, and we can rename those computed fields using the as keyword. If there's a pattern that you want to match and use a wildcard, then you use the star or asterisk character. There are built-in aggregate functions, count, sum, average, max and min, to do statistics on groups of records. And to figure out what those groups are, you use the group by clause. And you can have cascaded SQL queries. So there'll be an inner query and an outer query, or there could be an inner query, a middle query and an outer query, or it could be even more complicated than that. And then when we want to join tables, connect them via their relationships, we use that where condition on the key, the primary key on one side and the foreign key on the other, that's connecting those two tables. We can use union to combine the output of two queries. We can use the update command to change existing data. We can use the insert command to add new data to a table, or we can use the delete command for deleting existing records. And it's a pretty universal language. There are some slight differences across those databases that I mentioned before, but not too many. And I think that's pretty much it. That is Module 3. I do have something else I want to talk about, but I'll create a new video.